Today, our group is Group 6. We introduce about our group assignment is about column coordinate measuring machine, CMM. We have 4 members in our groups. For number 1 is Nur Amida Syafiqah binti Nazrul Hisham. The number matrix is DB240071. For the second person, Nur Shahira Yasmin binti Razali, DB240009. And my name is Nur Sharafa. My matrix number is DB240060. And Nur Awatif binti Shahrul Anwar, DB240136.
This slide is an introduction to the coordinate measuring machine or CMM. A CMM is precision measuring device used to inspect and measure the geometrical dimension of an object accurately. It is commonly used in manufacturing industry or quality control and inspect purposes. The machine uses a probe system and computer software to collect measurement data, which helps reduce human error and improve accuracy. Among the different types of the CMM, the column type CMM is very popular because its compact design, stability and suitability for measuring from small to medium sized components with high precision.
Assalamualaikum, my name is Nur Al-Sawatif binti Shahrul Anwar. Number matrix DB240136. So here I want to continue about the role of CMM in industry. CMM in industry is a device used in industrial metrology that measure the size, shape and position of an subject accurately. It uses a probe that moves along 3 axes such as X, Y and Z to collect coordinates from the surface of workpiece. The measurements are then analyzed by computer and software system. A CMM is consists for 4 parts, that the body machines, measuring probes, control system and measurement software. It's widely used for dimensional inspections, quality control, reverse engineering and assembly verifications. CMM is commonly used in automotive, aerospace, medical and manufacturing industry because they provide a high accuracy and a reliable measurement.
CMM has 4 main operation modes. First is manual mode, where the operator can control the machine completely by hand. The probe is moved manually along X, Y and Z axes to measure the workpiece. Second is manual computer assisted mode. In this mode, the operator still moves the probe manually, but the computer giving digital readings, instruction and automatical calculation. And the third one is motorized computer assisted mode, where the machine movement controlled by joystick or control panel. Lastly, direct computer control, or we can call it DCC mode, is fully automated. The machine follows a pre-programmed path, collects data automatically and generate inspection without human intervention.
My name is Nur Sharafa. My matrix number is 240060. I will introduce my part is about function of each CMM accessory. For 1, feature plate act as the base to hold the workpiece during inspection and keep the workpiece stable and prevent the movement. Content threaded hole for attaching component and features. Support accurate and secure measurement setup. For number 2, clamp. Is it about secure workpiece tightly on the feature plate or CMM table? It's about to prevent the vibration and shifting during measurement. They have a type of clamp, include like tension clamps, body liquids, heavy duty column clamps and also magnetic column clamps. It provides flexible and customized holding solution. Turntable. It's about rotates component for easier multi-angle inspection. Must support the required mass and as a component, require high rotational accuracy to reduce the tolerance errors. It should integrate with CMM software and also need thermal stability and protection from dust or oil before the production environment. For number 4, step gauge. Position used for CMM calibration and verification. It for test linear and volumetric accuracy, and also consists of accurate parallel gauge blocked with fake distance, which may measure length errors in different orientation. And also it provides traceability to national or international measurement standard. For number 5 is about standard sphere. It used for calibration CMM probes, and also it for checking machine accuracy. Also called as a reference sphere or datum sphere. Common size range from 10 mm to 50 mm. The standard industry size usually 25 mm, like 1 inch, made from material with a low thermal expansion, such as alumina ceramic, and also tungsten carbide and stainless steel. And for the last, precision inspection template, establish alignment and datum reference system, match CMM coordinates with engineering drawings. So for the datum reference, literally have 3. For first, primary datum from flat bottom plane. The secondary datum B is from side edge rotation, and for the third is tertiary datum C, is from about location hole for origin setting. It supports balloon drawing and automated reporting, and also it improves when the inspection accuracy and consistency. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Amira Shafiqa binti Nazrul Syam, and my number matrix is DB240071. So right now I'm going to present to you about the working principle step by step of column coordinate measuring machine. So the working principle need to be done step by step to ensure the alignment process using the column coordinate measuring machine is carried out correctly. This is because if the step taken are wrong, it will affect the result of the material alignment and will interfere the next process. Here are the steps that needs to be done. The first step is setting up the coordinate system. So the coordinate system is the main thing that needs to be done so that the start of the measuring process occurs without error. This machine will define the 3 orthogonal axes, which is X, Y, and Z. So these 3 axes are the movement of the machine to measure the material in the 3D form. The second step is probe initialization. So the probe will touch the surface of the material where the conclusion process will begin. Before that, the probe will be checked first to ensure that it can function properly. This is because the probe function to touch the surface of the material obtain the measurement calculation. Therefore, the probe needs to be calibrated so that the conclusion read are accurate. The third step is workpiece placement. So the workpiece will be placed on the measuring table on the column coordinate measuring machine and will be clamped securely so that the material will not move throughout the measuring process. So the workpiece also needs to be placed in the correct places because the datum surface will be identified on the material and will be the reference point for the measuring process. The fourth step is contact measurement. So the measurement calculation process begins. The probe will move on the workpiece according to the 3 axes, which is X, Y, and Z, and then will touch the material. The probe's contact with the material will be detected and the measurement calculation will be read based on the axis taken. The fifth step is data acquisition. The probe contact with the material will obtain a measurement reading and the sensor on the machine will convert the reading to a digital coordinate value.
So the taken value will be stored relative to the specified origin. The sixth step is software processing. So the collected value will be processed through the software contained in the CMM. So geometric feature readings such as length, diameter, angle, profile will be reconstructed from the point cloud on the machine. The seventh step is comparison and analysis. Once all the workpiece reading has been taken, the reading will be compared with the drawing that have been done in the CAD software or tolerance specification to see if the measurement and drawing made is similar or not. If all the specifications set are correct, the following process will be carried out. The last step is report generation. So the system on the machine will automatically generate the measurement reading for inspection report. The result include the dimension of accuracy, alignment and compliance with the standard. Next, I will pass to the next presenter to present about the stylus calibration methods.
Probe calibration is an important process in coordinate measuring machines, such we call CMM, because the accuracy of the probe directly affects the accuracy of measurement results. So, the probe usually has a spherical stylus tip that allows us to measurement in different directions. So, before calibrations, the probe components such as the probe seat, stylus and extension rods, and standard ball's diameter is to measure is defined in the measurement software. So during calibration, the probe touches the several points on a standard sapphire that normally from 7 to 11 distributed points are measured to obtain the accurate data. And then the software then analyzes the collected X, Y, and Z coordinates to calculate the ball centers, diameters, and shape error. A small standard deviation is better indicate repeatability for enhanced higher accuracy. For multiple probe, the position is to calibration process is repeated to ensure that probe angles and position produce similar results. And finally, the correction value is obtained by comparing the measured ball diameter with the standard ball's diameter. This process is help us to improve the reliability and precision of CMM measurement in industrial applications.
So right now, I'm going to present about the safety precautions during CMM operation. There are 5 safety steps while handling the machine. The first one is work environment. So the work environment should always be checked to ensure that the work area is safe and clean and does not have any hazard that can cause the risk of the accident. Make sure the room temperature is always consistent and suitable for the machine being used to avoid the material expansion. In addition, avoid vibration from other machines that can cause disrupt the machine process while it is running. The second step is handle the probe with care. The probe is a sensitive tool and can be easily damaged if used incorrectly. Therefore, do not use the probe with excessive pressure when touching the surface of the material. Avoid touching the probe directly with your hand and also always check the probe by calibrating it periodically before use. The third step is ensure the position of workpiece is safe. The workpiece must always be clean and be locked to the measuring table stably to prevent the movement. The workpiece must be locked using a jig or clamp that is appropriate for the type of the material being used. In addition, make sure the material does not move during the measurement process and avoid placing excessive loads on the measuring table. The fourth step is operator safety. So avoid injury when operating the CMM. It is forbidden to place hands on the exit parts during the machine process because it will interfere with the measurement process and will cause the injury to the operator. In addition, it is forbidden to stop the machine manually and must follow the instruction and safety regulation that have been set. The fifth step is perform periodic inspection. So periodic inspection such as calibration and maintenance must be carried out to ensure that the machine and tools used are always in good condition to ensure the measurement accuracy, such as periodically calibrating the probe, checking the electrical and mechanical system, and documenting all the maintenance activities that